Intermediate Algebra for Statistics, Simplifying Radical Expressions Part 2. Lesson Objectives. Use the product property for square roots to simplify radicals. Use the quotient property for square roots to simplify radicals. Product property for square roots. Consider the following computations with radicals. The square root of the product of 4 and 9. 4 times 9 is 36, so the square root of 36 is 6. Now what if we look at the square root of 4 times the square root of 9? Square root of 4 is 2, because 2 squared is 9, and the square root of 9 is 3. 3 squared is 9. 2 times 3 is 6. Since both results are equal, we can write the square root of 4 times 9 is equal to the square root of 4 times the square root of 9. This equation suggests the following product property for square roots, which can help us with the principal square root of a product. We can sometimes write a radical as an expression with the smaller radicand. For example, consider the square root of 28. Note that the perfect square 4 is a factor of 28, because 4 times 7 gives me 28. So we can take the square root of 28, write it as a product of 4 and 7, and then use the product property, split the square roots up, and finally take the square root of 4, and we get 2 times the square root of 7. So the radicand is no longer 28, it is 7. When writing an expression such as 2 times the square root of 7, we write the 2 to the left of the square root of 7. If we were to write the expression as square root of 7, 2, the radicand might appear to be 72, not 7. A square root is simplified when the radicand does not have any perfect square factors other than 1. Property. For a greater than or equal to 0 and b greater than or equal to 0, the square root of a times b is equal to the square root of a times the square root of b. In words, the square root of a product is the product of the square root. Let's do an example using this property. Simplifying expressions with square roots. Example 3. Simplify. Number 1, square root of 20. Number 2, square root of 32. Number 3, 2 times the square root of 75. All three of these examples are not perfect squares, but in order to simplify, we want to make sure that they do not have a perfect square as a factor. Solution. Number 1, square root of 20 has 4 as a factor. 4 times 5 is 20. Using the product property, we can take the square root of the product 4 times 5 and write it as the square root of 4 times the square root of 5. Since the square root of 4 is a perfect square, we take the square root of it. Square root of 4 is 2, and then that is being multiplied by the square root of 5. So square root of 20 is the same thing as 2 times the square root of 5. To verify this using a graphing calculator, we type in the square root of 20 and we get approximately 4.47, and we take 2 times the square root of 5 and we get exactly the same answer. Number 2, square root of 32. So we need to think, what is the largest perfect square that will divide into 32? Now 4 is a perfect square and it will divide into 32. So it is a factor, but it's not the largest factor. The largest is 16. 16 times 2 is 32. Using the product property, we can write it as the square root of 16 times the square root of 2. Square root of 16 is 4, so we have 4 times the square root of 2. And sometimes in short we say 4 radical 2. Radical 32 is the same thing as 4 radical 2. We can verify this on the graphing calculator and we see that these two answers are equivalent. Number 3, 2 times the square root of 75. So we are interested in the radicand. Does it have a perfect square as a factor? 25 is a perfect square, and it will divide into 75. So we can rewrite this as 2 times the square root of 25 times 3. Using the product property, we could split this up as the 2 times the square root of 25 times square root of 3. Square root of 25 is 5. So we have 2 times 5 times the square root of 3, which gives us 10 times the square root of 3. So we can say 2 radical 75 simplified is 10 radical 3. Again, we can verify this on a graphing calculator. We see these two radical expressions are equivalent. Process. To use the product property to simplify a square root, number 1, write the radicand as a product of the largest perfect square factor and another number. Number 2, apply the product property for square roots. Lesson objective: quotient property for square roots. Here we compute a square root of a quotient and a quotient of square roots. Square root of a quotient: the square root of 16 divided by 9 is equal to 4 divided by 7, because if you take 4 divided by 7 and square it, you get 16 over 49. Quotient of square roots: square root of 16 divided by square root of 49 is 4/7. Since these two results are equal, we can write square root of 16 divided by 49 is equal to the square root of 16 divided by the square root of 49. This equation suggests the quotient property for square roots. Property: for a greater than or equal to 0 and b greater than 0, the square root of a divided by b is equal to the square root of a divided by the square root of b. In words, the square root of a quotient is the quotient of the square root. Let's do an example. Example 4. Simplify the square root of 7 divided by 64. Solution: square root of 7 divided by 64 equals the square root of 7 divided by the square root of 64. And this is from the quotient property. Square root of 64 becomes 8. So our final answer is radical 7 divided by 8. To verify this on the graphing calculator, we see that these two expressions are equivalent. Thanks for watching.